Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
It is time for Engineering Tomorrow. I am your host, Brian Gomsky, and we are doing something a little different this week. We will be replaying a awesome webinar that we did a couple weeks ago about cooling tower life hacks. Now, what is a cooling tower life hack? It's kind of thinking about purchasing a car. You don't want to purchase the base model. You want to make sure you get all the options you want, like remote start, power doors, window tinting, leather seats, and anything you can think of. When you purchase a cooling tower, unless you specify all those options, you are getting absolutely nothing. You are getting a box with hot water that goes into the top and cool water that comes out the bottom. What if you need to get into that tower? What if you need to climb up to the top, replace a gear drive, replace the oil? Well, guess what? If you don't specify all those options to make it safe and easy to do, chances are you're not getting those options when you get your cooling tower. Today, we're bringing in Ryan Miller and Troy Gladstone, two veterans in the cooling tower industry, probably 40-plus years combined experience. So do me a favor, get comfortable. If it's the morning, grab yourself a coffee. If it's the afternoon or if it's 5 o'clock somewhere, go ahead and grab yourself a cocktail and get ready to be completely riveted by these two gentlemen talking about cooling tower life hacks. We'll see you after the webinar.
Hey, good morning, everybody. Welcome. Glad you could join us. For those of you who don't know, I saw there's a few participants here who maybe I haven't had the pleasure of meeting face-to-face. My name's Ryan Miller. I'm with Midwest Machinery here in Kansas City. You may see on the other screen here, Troy Gladstone, who's joining us from St. Louis.
Hey, everybody. So what's the agenda for today?
Yeah, so I thought what we'd do for our first session here, and we do plan on doing more of these, so be prepared to look for more of these in the future. But I think we'll start with just kind of a cooling tower life hacks, just kind of things to make your cooling tower life easier. The definition of life hack, for those of you who don't know, and it took me a while of hearing it before I actually understood what it means, but it's a strategy or technique adopted in order to manage one's daily activities in a more efficient way. So today we're going to talk about cooling towers and kind of take the approach of Troy and I, what would we do if this were my cooling tower? Like if you're talking to the doctor and you say, my kid's sick, what would you do if it were your kid? Well, if it was my cooling tower, here's what I'd like to do. And so we'll talk about some things that often get overlooked, maybe aren't known about, forgotten about, or maybe they're not specified in the front end, but they're a great benefit to the owner and user on the back end. And just trying to make people aware of some of the options that are out there so those conversations can be had and hopefully people get the most efficient accessories and configurations for their cooling towers.
We had a bunch of different topics to call this thing. One was cooling tower hacks. Another was if it were my tower or my building, I would do this. I always used to call this the no specky, no getty, meaning, I'm sure we got a bunch of engineers here and end users and owners. I'd remind everybody that, most of what we're talking about here are enhancements to a cooling tower. And if you don't, as a specifier, put these in, you won't get them. Or as an owner, if you want to make sure to get them, talk with your Midwest Machinery rep to make sure that they help the engineer get that written into the specification. All right, cool. Yeah, so I think I wish we had the David Letterman top 10 music and audience applause here. But for me, hack number one is what type of cooling tower are you going to specify? The awesome thing about working with Marley, our company is we've been working with Marley almost 100 years now, is that Marley invented and designed just about every type of cooling tower out there. And the good ones they still offer, the lousy ones that they invented and designed, they've long gotten rid of. So we don't have an axe to grind, so we're always able to recommend the right tower. So when you talk about types of cooling towers, for 80% of the applications out there, you're going to choose between a counterflow and a cross-flow cooling tower. So to me, 95% of the time working with clients and customers, I'm going to recommend a cross-flow cooling tower as opposed to a counterflow tower. Biggest reason that end users really prefer cross-flow cooling towers over counterflow is the ease of maintenance. You can get inside the plenum, you can get to the distribution system, you can work on the mechanical equipment, all from safe spots within the cooling tower or from the exterior of the cooling tower, as opposed to a counterflow tower, which you can, if you can see in that blow up, almost all of that is in a very tight confined space. Getting to the distribution system to look at a clog, it's almost impossible. You definitely can't do it while the cooling tower is running. Same with the mechanical equipment. It's just the benefit of a counterflow tower is its compact footprint, but that's just about it. So it's easier to maintain. Typically, the pump head requirement is less because the cross-flow tower uses an open gravity type system, whereas the counterflow tower uses a spray type system. And then let's see, cross-flow towers are usually a little bit shorter than the counterflow towers because it's footprint based. Really, that's the big three for me. Did I miss any of the superior benefits of cross-flow versus counterflow?
No, I think those are the big ones. Like you said, we could spend an entire hour talking about this topic, but those are, I think, the key factors.
A lot of people think that cross-flow towers are more expensive, and dollar per ton, they're not really. The reason they seem to be a lot more expensive is because you can customize a cross-flow cooling tower a lot more than you can a counterflow cooling tower. So heavy users, universities, hospitals, folks that have dozens of these on their sites, they've gotten to be accustomed to a lot of the stuff that we're going to talk about here in a minute. They've been life hacking their cooling towers, and therefore they've got a lot of really nice custom options on them to make their life easier. But at that comes a little bit of more initial cost. So that's my vote. Crossflow, number one. Ryan, why don't you go with your first life hack?
Okay, yeah, absolutely. So the first thing that I think of when I think of things to make your life easier, particularly as an owner, is the drive system. So Marley has standardized, and for good reason, on gear drive versus belt drive. In almost all of their models and configurations, they can provide both. But what they've found over the course of time and with their gearboxes is that there's a lot less maintenance involved with a gearbox versus a belt drive. Now, they don't have the hamster wheel in place yet. I think research and development is still working on that. That might even be less maintenance if we ever get that put into place, other than feeding the hamster. But when you look at gear drive versus belt drive, for belt drive, you're going to be tightening your belts several times a year, replacing your belts probably at least once a year. Just a lot more getting into the tower and putting your hands on the drive system. With a gear drive, you're really only checking oil and then eventually changing oil. And I'll talk in a minute about how frequently you have to change the oil. But checking the oil is very simple compared to having to tighten belts and replace belts. Another big advantage for gear drive versus belt drive is energy transfer. You're going to get upwards of 95% of the energy that you're paying for coming out of the motor going through the gear drive into the fan. With the belt drive, especially over time, as it starts to loosen up, you'll start to get some slip and some things like that, and you'll start to really lose some of the energy you're paying for in the motor getting to the fan itself just through belt slippage. Another thing that you'll find is with a gear drive, there's consistently low noise. With the belt drive, kind of depends on the age and the tightness of the belt. You might start to get some squeaking, some things that are going to be potentially annoying to neighbors or folks around the tower. So those are kind of the big three of gear versus belt drive: is the maintenance aspect, the energy transfer through the drive system, and noise. Now, the one kind of drawback to a gearbox is when and if it ever fails, it is a little bit more costly and a little bit more difficult to replace. But with a good gear drive, that's something that rarely has to be done. And so let's talk about that for a minute. The Marley gear drive in particular comes with a standard 5-year warranty. So Marley builds a very, very good gearbox that is designed for cooling towers, and it's going to last you a long time. The other interesting thing about a Marley gearbox is with synthetic lubricant, which is what most people use, you can go 5 years without an oil change. So back to the conversation about maintenance, if you're just checking the oil and only having to replace it every 5 years, that's very little labor that you're putting into that thing over the course of time. So
that kind of goes back to an interesting point there is, that's all standard with Marley, but every of the 3 major cooling tower manufacturers, everybody can do it. So that's kind of one of those no specky, no giddy items. We would recommend that you specify a gear drive, specify a 5-year warranty and a maintenance-free warranty, specify that the gear drive is suitable for variable speed operation without an external oil pump. I know I'm kind of getting into the weeds there, but specify usage of external oil pumps is not allowed, and then specify that it use synthetic oil. And you do those 3 things, it doesn't cost you a penny extra, but just makes sure that you end up getting the gear drive that's going to, frankly, last for a very, 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 very long time.
One other quick thing in the no specky, no giddy, if you choose to go with the gear drive, you'll want to put in there that you want lube lines and a dipstick also to make life easier. All that does is
definitely
the ability to check the oil from not at the gearbox, which is inside the plenum of the tower. Gives you the ability to check the dipstick on top of the tower, which is very easy to get to, and you can do that, really without having to worry about getting inside the tower.
All right. So that brings me to our hack number 3, which is now that we've agreed that we're going to put the gear drive in the cooling tower, for us it's standard. We can provide belt drives, but the gear drive is standard. Where do you put the motor? I'm a huge believer in motors outside the airstream. Because we have a maintenance-free gear reducer, essentially, especially when you add the lube lines to it, there's no need to get inside of the cooling tower. We have found that if you stick the motor inside the cooling tower, it doesn't get maintained, and it is not maintenance-free. So we recommend extending the motor outside of the airstream with a drive shaft that gets balanced during installation. And the other thing, and probably most importantly, is it really extends the life of the motor. Granted, we are always recommending a TEFC, premium efficient motor. So it should be able to handle pretty much any atmosphere that we put it in. But putting it outside of that warm, moist airstream really extends the life of it. So my nomination for a great hack is motors outside the airstream. And then I like to add a little bit to it and put a what we call a motor access platform on that. And I don't know if I'm stealing the thunder for another life hack, but you can see I am stealing the thunder. Okay, all right, I'll shut up. I'll shut up.
Guys, I've got a relevant question. Corey Futrell asked, does Marley have guide specifications available to help engineers correctly specify gear drive features?
That almost sounds like a plug question because that is a fantastic and relevant question. Corey's obviously a very intelligent person. Yes, of course we do. It's part of our standard guide spec. But, typically we like to tweak it a little bit more to put a little bit more teeth in it because we found that if you don't specify certain things, so maybe that's something that we put out as a follow-up to this is a simple blurb. What do you think, Ryan?
Yeah, absolutely. We can get that out, and we will.
Okay.
I don't know if this would be a good time. Sorry for going off script, but we talked about belt drives and gear drives. And we didn't talk about a new trend in our industry that's getting some commotion, not a lot of traction, but it's the direct drive option, which is essentially instead of having a gear drive or a belt, we put would directly mount the fan to a specialized motor. And correct me if I'm wrong, that's a Baldor motor. So basically the motor replaces any drive components. And it's really intriguing product. It's been out, I think, for about 10 years. And we're starting to see some specifications in it. And, I don't want to sound like a flat earther here, but I would never put one of those on my cooling tower. And I'll be interested in your comments, Ryan. But while it's a very cool product and we get rid of belts and we get rid of gear drives, we've now put a very, very, very specialized motor in that only one manufacturer in the world makes, Baldor. And it's not one that's commonly stocked. Midwest Machinery Company here in Chesterfield, we house I know we have the world's largest inventory of Marley cooling tower parts, but because we're a partner with Marley. But I think we've got one of the bigger inventory of cooling tower parts. We don't have any of those in stock, and very, very few people stock those direct drive Baldor motors. But we've got belts, bearing assemblies, gear reducers, motors. You can get a motor from any local ESA repair shop. So for my money, if it's my facility, my institution, I like the idea of the direct drive, but I don't like the risk that comes along with it. So I probably just kind of grandstanded there. Didn't leave you much, but how do you feel about that, Ryan?
I guess the first thing I'll say that is if you're just dead set and sold on a direct drive, it is something that Marley will do for most models as a special. But I would agree with Troy. And some of the things that you want to think about if you're considering a direct drive, first of all, it's a much heavier piece of equipment than both the gearbox and the motor combined. So you're oftentimes, if you do that as a special on a cooling tower or add it to a cooling tower, you require extra structure and the unit weighs more. Also, if it does happen to fail, if, like Troy said, if you've got a motor and a gearbox and the motor fails where you're just replacing the motor, which is a pretty off-the-shelf item, and then you still have your good gearbox, right? So your cost is lower and it's easier to get. If that direct drive fails, then you're kind of in trouble. And then the other thing to consider is my understanding of the way all of these work is that you have to have the VFD connected for the direct drive motor to be able to run. So if your VFD goes down, you don't have the ability to run the direct drive in bypass mode like you would if you just had a standard motor with a gearbox. So there's an extra fail point without a plan B in terms of the VFD going down if you go with a direct drive. So just some things to consider. So, okay. Are we on hack number 5? Portable.
The next one.
What do we got? There we go. Hack 4. Right. Portable crane. So this is something that can be very useful. So one thing that you want to consider is these are, if instead of getting a crane, if you need to replace your mechanical equipment, you can have a davit and really a portable crane and a hand winch that allow you to remove the mechanical equipment. And the unit that Marley provides has an extension on it that allows you to be able to drop that equipment down to the ground. So if you do specify this, though, the one thing to be careful about is there are also davits out there which are different than a portable crane with a hand winch. Basically, a davit is just a place for a customer to attach their hoist. So it wouldn't have the extension on it, and it also wouldn't have the winch that comes with it just as part of the unit. The other thing that Marley does with the unit they offer is they make it portable. So if you have multiple cells and you've got a fan deck walkway going across all of your cells, you can just buy one base for the portable crane and then use that portable crane for all of your different cells down the line. So it can really save you on cost, still give you the advantage and the ability to use that thing. A couple of cautions one thing is if you have a velocity recovery stack on your tower, you want to you can still use one of these portable davits, but you have to remove a section from that velocity recovery stack to be able to put the davit in to be able to use it. So you'll need to evaluate that trade-off in that case.
So for the non-cooling tower geeks on the webinar here, a velocity recovery stack is essentially a 6-foot tall fiberglass cylinder that is used in place of the standard shorter fan cylinder that basically gets us another 1 or 2% of efficiency out of the cooling tower.
Or more. Yeah, so the velocity recovery stack can keep you in a smaller box size by increasing the efficiency. So,
right.
It's usually not a trade-off where you're going to say, oh, just don't give me the velocity recovery stack, because it probably means you're buying a bigger tower at that point,
right?
In order just to get the portable davit. So just something to consider. I've also seen people specify and use these without the intention of actually using them for the mechanical equipment. They just use them to get oil and or tools up to the fan deck, which is another good usage of that piece of equipment.
Yeah, this is something we probably, in addition to the gear reducer guide spec, we should put a guide spec out on the crane, because if you're not specific about what it looks like, we've seen some manufacturers will actually just fabricate a very, very simple post and beam that doesn't have any structural ratings on it, and it's awful. But yet they're able to check off the box to be able to say, yep, we gave you a davit.
You're listening to Engineering Tomorrow, always striving to bring you the best in commercial construction, design, and engineering.
So actually, this is a favorite of mine, fan deck extensions. And it's a relatively inexpensive one. But in the race to put as much performance within a footprint, the fans on these cooling towers have gotten bigger and bigger and bigger. And they essentially, especially in cross-flow towers, they take up the most of the fan deck. So when you have multi-cell towers, it gets really difficult to move from one cell to the other. So oftentimes what you have to do is you have to, if you're on, let's just call it a 3-cell tower, or maybe just a 2-cell tower. If you're on cell number 2 and you want to get over to the opposite basin on cell number 1, you've got to climb down sometimes a 20 to 25 foot ladder, go across the tower at grade, and go back up the other side of the ladder just to move 15 feet. So if we specify and supply the towers with this fan deck extension, which is simply a cantilever that you can see, you gain the entire access to the fan deck. And in fact, it is less expensive than an extra set of ladders and safety cages. So I think oftentimes it can be a savings in addition to a huge headache savings, as opposed to multiple ladders and safety cages. So my nomination is fan deck extension.
The next thing that I think is really simple and can make your life a lot easier is making sure that you take time to consider the ladders, guardrail, safety cages that you want to put on your tower. So as Troy mentioned, one of the big benefits of a cross-flow tower is your ability to access really all parts of it. And so that fairly easily. And so that includes getting to the distribution hot water basin deck. And that can be done from the top of the tower in a very comfortable way. But so you need to make sure that you've included ladders to get to the top of the tower and guardrails to be able to safely walk around the fan deck. One thing also to keep in mind is the safety gate at the top of the tower, or at the top of the ladder, is not standard. So you want to make sure that you specify, if you want a safety gate, that you include that. Now the safety cage that goes with the ladder per OSHA is required on any ladder that's 24 feet or taller. If you want one for safety, even without, in addition to OSHA compliance, you can certainly specify that for shorter towers as well.
Hey, Ryan, an important note for anybody putting together a tower specification or layout is you can see in that picture the safety cage has to start approximately 7 feet above grade or the roof or whatever it is. So it's really important to make sure that we know exactly what the elevation of the supporting steel is, because if we just make an assumption that it's 3 feet, then we're going to Marley's going to, build that safety cage so that it's 4 feet from the bottom of the tower to get that 7 foot dimension. And if indeed the gap was 5 feet, not 3 feet, then we're out of OSHA compliance at that point. So it's super critical that at least in the submittal process, we make sure that dimension's correct. We've seen a lot of towers that have to go through reconfiguration in order to fix that.
And that can work against you if you overestimate that distance without knowing it as well, right? So you can end up, if you assume it's a 5 foot distance and it ends up being a 2 foot distance, now your safety cage is hitting you right here and you have to duck underneath it. So,
absolutely.
But yeah, you want to make sure you define that before we start building anything, for sure.
Go to the next slide.
Yeah, so one other important note or point is a lot of times cooling towers are height restricted, typically for aesthetics. Yeah, go to the next one, Brian.
Oh, yep.
Yeah, this one right here. So, which doesn't make any sense to me. I can't understand why anybody would ever want to try and hide a cooling tower behind anything. But people do, and they want to hide the guardrails as well. So if you're kind of at that cusp where we're higher than we need to be just with the guardrail that's up there, we can still get you access to the hot water distribution basin without going any higher than just the top of the tower. And the way we do that is with what's called a louver face platform. This is a little bit more costly. Which way go? No. A little bit more costly than just standard fan and ladder and guardrail. But this way you can stand, 3.5, 4 feet below the top of the tower on a very comfortable platform and have access directly to the hot water basin in front of you. So if you're height restricted, don't just assume that we can't make that work. We can put a louver face platform on there and you'll be good to go.
In a similar note, we do have the ability. So you were just showing a louver face platform to get up to the hot water basins. Correct. For height restricted. We've done a lot of cooling towers with what we call a cold water basin louver face platform. And, sometimes we have users that want to have a walkway all across the base of the tower. So we're starting to see this become more prevalent. Brian, sorry for ripping this piece of artwork off the wall.
Yeah, that's fine.
We'll put it back later. All right, so hack number 7, that's me. So it's film fill thickness. So before I talk about that, I would say the great majority of the cooling towers that we sell, and even in the industry, are predominantly stainless steel. Seldom are we supplying an all galvanized steel cooling tower. Often we're taking a galvanized steel cooling tower and adding stainless steel hot and cold water basins to it. But more and more, we're supplying the whole tower with stainless steel. So you take an entire structure that's stainless, you put a mechanical equipment system that's got a VFD on it and a 5-year maintenance free. That cooling tower is going to last for a very, very, very long time. So what ends up becoming the weak point in the entire piece of equipment is the film fill itself, which is the heat transfer surface. So it's kind of the heart of the cooling tower where the action's happening. The industry has standardized on 12 mil PVC, which I'm just going to say from my point of view, I hate. I think I would not personally want to put a tower on a rooftop that didn't have 15 mil PVC in it. It's about 25% heavier material. It doesn't cost an extra 25% to do it. but it gives you a much longer life expectancy on that fill. It doesn't, with Marley, it doesn't change the factory mutual approval status of the cooling tower. Really, it's just a beefier substance. When the industry started moving to 12 mil, frankly, we started seeing, with every brand of cooling towers, we started seeing more water leakage issues because in cross-flow towers, this fill hangs. And so the thinner it is, the more apt it is to stretch. So that fill becomes a little bit looser, and the looser fill allows for more areas of leakage. So to me, my money, this might be, in my opinion, the most important hack, but I feel strongly about it. Sorry, I'll calm down.
No, it's a good one. It's a good one, Troy. So.
Yeah, thank you. Thanks for your positive encouragement. All right, moving on.
Yeah. All right. So the next thing that you want to make sure that you consider in terms of ease of access to a cooling tower is things to make things easier inside the tower. So when we do have to access the inside of the tower, we have immediate access to the eliminators on the backside of the fill, immediate access to the cold water basin itself, as well as all of the mechanical equipment. If you have the motor inside the airstream, it's in there, the gearbox, the fan, all of those things. So we want to make it easy to be able to move around inside there. Again, one of the nice things about a cross-flow tower is it does have a nice big open plenum. So you're not, I always make the analogy or the comparison to a house with a full basement versus a house with a crawl space. So for a cross-flow cooling tower, I think of that as like a house with a full basement. You have plenty of room to access all of your mechanical equipment, have your tools, move around freely and safely. In a counterflow tower, it feels to me more like a home with a crawl space where to get into the mechanical equipment, you're in a space that's 3 feet high and you're crawling in and you're uncomfortable and it's not as safe. But so with that inherent ease of access to the plenum area that a cross-flow tower brings with it, might as well put a platform in there so you don't have to put waders on when you're walking across the cold water basin, and we call that the plenum walkway. In addition, in order to not have to bring a ladder in with you or have to climb up on anything, we have a mechanical access platform. So you can stand comfortably and work on the gearbox, the motor, and the fan from inside the tower. And then lastly, just being able to get in the tower, if your tower is elevated at all up on grillage, it makes it a lot easier if you have an access door platform. So you have room to stand there, open up the door, and just step inside the tower versus having to kind of crawl up or have a ladder there and then work your way in through that door. Again, that's one of the advantages of a cross-flow tower is the full-size door that you're able to crawl through versus on a counterflow tower where you have a much smaller door that you have to, you can step through the cross-flow door. On the counterflow door, you have to crawl through. So, but it certainly, the maintenance crew, the facilities crew is going to thank you a lot if you provide these types of platforms and make their life easier for access.
All right.
Yeah.
Certainly a good, important hack. And that's kind of one of those examples where the perception of the cost of a cross-flow tower might seem more because as our customers get some of these platforms, they start asking us, well, can we put a platform here? Can we put a platform there? It's kind of like building a custom air handler. We could do just about everything, and most of it's all standard products at this point. But it's like buying a car. You don't want to buy a car without power locks anymore, and that's what a lot of these platforms have become. All right, so moving on, please. Hack number 9 is deals with the inlet configuration. There's many inlet configurations on these cooling towers. The standard configuration is especially with cross-flow towers, is dual inlets. We have 2 hot water basins, so you get a hole and bolt circle at 2 spots on the top of each cell. we really like and we really recommend the single bottom inlet. In fact, almost all of the design build projects that we do are single bottom inlet. And the reason is because the designer is also the installer, and they realize that it's less expensive to pay Marley at the factory to provide the piping internal to the cooling tower than to fabricate and weld steel pipe on the external side of the cooling tower. So you can kind of see what it looks like from that ghosted in section there. But for me, it definitely saves a ton of piping and labor costs. Arguably, we save pipe and therefore we save some system pressure. And lastly, it kind of looks better. And one that we don't give enough credence to as well is we tend to have a better balance on the system. So what we'll do is we'll put a simple valve on the inlet of each cell rather than two valves on each cell. So we're able to get a really good balance across cells with the bottom inlet piping. So hack number 9, single bottom inlet. So moving on to hack number 10. I think, is this our last one? Ryan, it's yours.
It is. And folks, this is the latest and greatest, newest hack. This is something that Marley just came out with, so it's just now being introduced. And this is a great one just because of its simplicity and its ability to really help your day-to-day operation of the cooling tower. What it is called Marley Basin Guard, and it's simply a nylon filter that goes in the hot water basin. It's held in place by a stainless steel grid, and it captures any large debris that may be coming into the hot water basin and prevents it from getting into the nozzles and the cups and clogging those up. So it could be like pipe scale or rust or any other large debris that may find its way into the piping system or even just into the hot water basin naturally.
Birds, leaves, all kinds of scuzzy things get into the cooling tower.
So it's going to keep your cooling tower working more consistently and more predictably by having the uniform flow over the fill, because you don't have clogged nozzles because the filter has captured those things. And you may say, well, that filter is going to just prevent water from flowing into the nozzles themselves, but it doesn't. This is a gravity flow basin. So it was tested with up to 75% blockage with large debris and still met the head requirements for getting water into those nozzles. So most towers require typically monthly cleaning of the hot water basin. By putting this filter in, you eliminate all of those cleanings, and every 6 months, so twice a year, you simply replace that filter. The stainless steel grid stays in place.
This is such a simple, clever idea. I'm really pretty upset that I didn't think about it a long time ago. Right. But it kind of, if you've already specified cross flow and now we have the maintenance access items to get to it, and hot water basins, this is kind of a no-brainer as far as I'm concerned. It's such a huge benefit.
And so the nice thing about this also is it can be specified with new towers. It's also, just because of its simplicity, easily retrofitted to existing both Marley and even competitors' towers. So certainly if it's something you as an owner or if you're a service contractor and you think this would help your accounts, let us know. We can certainly get you a quote for this great, simple hack.
Ryan, you want to close us out?
Yeah, folks, I just, again, appreciate you taking the time to join us this morning. Hopefully this was good use of your time. Again, I think it's important that we, as an industry, do things like this to stay connected. Use this time where we're physically separate, but can still be, sharing knowledge and gaining expertise throughout this period. Don't know how long this is going to last. Obviously, we all hope it's sooner rather than later. that we're back at it and in our offices and out on job sites and meeting with each other and doing face-to-face lunch and learns and things like that. But we're certainly we're going to have more of these, because I know that we're not going back to work later this week. So as we do this, again, please, love to have your feedback. What did you like? What did you not like? What topics are you most interested in? Anything you can do to help us help you, we would much appreciate that. So above all else, stay safe and take care of each other.
Hey, we got a few questions, Ryan. So let's go ahead, roll through those.
Yep. First question is, from a specification standpoint, is the 15 mil measurement before or after forming?
It's before forming. So
it's a roll of a giant sheet of PVC. And actually, if anybody wants to, when we're allowed to again, Marley's got an awesome tour at the Olathe plant where you can see the fill being made. But it's all vacuum formed across a mold. So it's a really good question. So if you start with 12 mil and you pull it across a form, inherently the bends and the angles are probably going to be a little bit narrower than the 12. So to me, that's another reason why you should specify 15 mil.
Yeah, it's prior to forming is the only time you can really measure that, because to Troy's point, once you form it, there's going to be areas that are a little thicker and a little thinner throughout that chevron shape.
Josh McCluskey asked, is there an advantage of one type of tower over the other for free cooling applications?
I think so. I think the crossflow tower has significant advantages in cold water application. The challenge in counterflow towers is you have a plenum where the water is dropping some 3 to 4 feet oftentimes, and it can create a lot of splashing. And typically, when the ambient conditions are so low that we're using it for free cooling, we're trying to make 48, 49 degree water to go through a plate and frame heat exchanger to cool the process or the building. So we already have very cold ambient conditions, and we're taking our circulating water temperature down cold. So it's right at the point of freezing to begin with. And then we start splashing it, and the fans aren't running that much. They tend to ice up a lot more than cross-flow towers. The other thing with regards to free cooling application, it's all about freeze prevention. And it's definitely very much a trial and error. It's strange. We'll have some installations that are zero ice formation, work beautifully and flawlessly, and then we'll have other installations that seemingly have all the same characteristics on a job site, but they're, when we talk about being on the fine line of freezing and not freezing, they're on the other side. They're freezing more than they're not, and that's when we really need to engage with the operators and users to find out how low are they trying to drive that circulating water down. What does the fan control look like? What does their bypass control look like? There's a bunch of factors that can affect it. But I kind of grandstanded here again, but I think crossflow towers are, again, it's what I would put on my building, especially if I was going into a free cooling application.
Yeah, I agree. It's
good
easy.
Question.
We
have a whole lunch and learn on that topic that usually goes too long. So.
Just a couple more questions. Would you recommend an internal mechanical platform if we specify MOA with motor platform? Would the gearbox need it?
Yeah, I think it's still wise to go ahead and include that. First of all, just for aligning the drive shaft with the gearbox and the motor. That's something that has to be done in the field, and that makes it a lot easier to access that. And then also just ease of inspection of the gearbox. So I think it makes sense.
To me, if I go back to if it's my cooling tower and it's my building, I'm almost 50-50 on this. A lot of times I think about if I were pulling out my credit card and paying for it, my first thing I would do is put the platform at the motor. And then I would weigh the internal mechanical equipment platform. So, yeah, I guess I'd be 50-50. It just depends on what my budget looked like. And if I had a limited budget and I needed to spend that extra $1,000 on a fan deck extension or, some of the other hacks, that would probably be one of the later ones I would do.
Okay. Another person asks, I've read several specs that call for 150 pound, I'm guessing that's a pound, flange connections at inlet and outlet of tower in lieu of 125. Is that really needed for cooling tower applications? Does that add unnecessary cost?
So, get this question. So clearly a cooling tower doesn't have those kind of pressure ratings. So it really just comes down to bolt pattern. And what Marley has certified all of their connections to is the 125-pound bolt pattern. My understanding is the 150-pound flange connections are exactly the same for most, if not all, pipe sizes. So it's almost a moot point. I don't know, Troy, do you understand anything differently about that?
No, that's my same understanding.
Okay.
Yeah, usually by the time it gets out to the cooling tower, it's one of the lowest pressure spots in the system.
Yeah.
Do the HWB guards work with nozzle cups or dams?
So,
wow, that must be an internal questioner because I can't imagine many. Yeah. Sorry,
they do. I don't believe they've been released for that. For those options yet. They certainly do. I know I've dealt directly with research and development a little bit on this, and they've tested some of it at the R&D center. I think they're still working on doing some real-world actually installation testing of this thing when it's over cups and or dams. So I can double check on that. They're certainly headed in that direction. If it hasn't been released yet, it will be soon.
Yeah, I've heard the same.
Yeah. So.
And then just a couple comments suggesting to do a topic on cooling tower cleaning. And then can you provide a pricing sheet with all of the options you mentioned today? How does that work?
That's tough just because of the number of box sizes and the number of configurations and so certainly what we can do is it's pretty quick and easy for us to put a price together for a specific application with the different accessory options. So if you have a specific project that you're looking at, we're more than happy to walk through that with you and put that into our pricing software and let you know where it would come out.
Other than that, I guess, Ryan, you and I are out back to the grind, right?
Yep. Working.
All right. Cool. This is fun. Thanks.
Yeah, this is good. Thanks a lot, everybody. We'll see you next time.
Okay, we just finished listening to that webinar episode of Cooling Tower Life Hacks with Troy and Ryan. It was a great episode. Thank you again, and we look forward to having you listen to many, many, many more Engineering Tomorrow podcasts in the near future. Until then, keep engineering for tomorrow, today.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.